A circle is inside a square. The radius of the circle is increasing at a rate of 5 meters per minute, and the sides of the square increasing at a rate of 3 meters per minute. When the radius is 6 meters and the sides are 15 meters, how fast is the area outside the circle but inside the square changing? So we need to first come up with an equation for this shaded area here that's outside the circle but inside the square. So I'm calling the side of the square S and the radius of the circle R. And so to find this leftover area outside the circle but inside the square, I'm going to find the area of the square and subtract the area of the circle. So if I find my equation, the area of a square is S squared. So I take my side and square it. That's the area of the square. That's this here. And then I'm going to subtract the area of the circle. And the area of the circle is pi r squared. So that's this. So now that I have an equation, I can take the derivative. When we take the derivative, keep in mind that S, which is the side, that is changing with respect to time, and the radius is also changing with respect to time. So S and R are their own functions. So when I find the derivative of the area, I'm going to take this 2. Whoops, too big. Hold on. I'm going to take this 2 using the power rule, and I'm going to bring it down in front. I have 2 times S, and then because S itself is a function, I got to multiply by the derivative of S with respect to time. Minus, now this 2 is going to come down in front, 2 times pi times r, and since r is a function of time, I got to multiply by dr dt, that's the rate in which the radius is changing. And I want to evaluate this. The question says when the side is 15 meters and the radius is 6. So I'm going to plug in everywhere I have S, I'm going to plug in 15. So that's this right here, this 15 here. And everywhere I have R, I'm going to plug in 6. That's this 6 right here. Now this 2 and this 2 pi right here is already in our equation. So we just have to determine what the ds dt is and the dr dt is. Now that was given to us in the question. It says that the radius of the circle is changing at a rate of 5 meters per minute. So dr dt is going to be 5. And it also says that the sides of the square are increasing at a rate of 3 meters per minute. So that's our ds dt that I'm going to put in for 3. And when I put that all in on the calculator and I find that value, this is telling me that the rate in which the area is changing with respect to time is decreasing by 98.4955 meters squared per minute.